Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, with one of many videos available to you 24 hours a day, 7 days a week. In this session, we'll illustrate the use of several SolidCAM HSM strategies to machine the electronic box as shown on our screen. Now, if we go into our first operation, the HSR operation, you'll note we'll be using HSM roughing to mill out the part itself. If we go into the tool, you'll note that we're using a very large tool, a 30mm end mill, that's sticking out of the holder a very short amount. So a part like this, even it's a deep pocket, but you run the risk of crashing into the material over there. However, if we take a look at our holder clearance, we also have a holder clearance here as well, which will make sure that our holder will not collide into the stock itself. If we go into our passes, you'll note we're stepping down every 0.5 millimeter, and we're doing large step downs of every 10 millimeters. If we go further down, you'll note that our step over type will be cavity, since we're working in this particular case inside this cavity over here. So this is specifically meant to work inside the cavity. If we take a look at our simulation, you'll see that our tool will go in to the middle of the part, start a helical motion around the part itself, and now when it goes down to its next step, you'll note that it has a wider step away from the wall, and that's because it's making sure the holder is not colliding into the stock over there. If we go further down and then we take a side view of our cut over here, you'll see that our holder is actually inside the part itself, but again being moved away from the wall of the stock, allowing it to go as deep as possible into the part itself. In our next operation, we'll begin doing a roughing operation, but we'll be using the option of rest roughing, and this time using a smaller end mill of 16 millimeters with a 1 millimeter radius at the edge. And the tool will be outside of the holder by 30 millimeters, allowing it to go even further down into the part itself. If we take a look at our passes area, you'll see that we will again be leaving a 0.5 millimeter offset on the part itself, and this time going down every 5 millimeters. If we take a look at the simulation, you'll see that the tool is working only on those steps, clearing off those steps as it's going further down into the part itself, and only working in those areas until it gets to the very bottom of the part, and also cleaning out those pockets which the larger end mill cannot work in before. From this point on, we'll be doing our finishing operations, and we've broken this down into several different areas. Our first area that we're working on is the top flat surface over here, and if we go into the operation itself, you'll see that we'll be using the option of constant Z machining. The tool will be a 12 millimeter bullnose end mill with a 0.5 millimeter radius. And if I go down to the passes, you'll see that we'll be going down every 0.15 millimeters, and we'll only be going down 5 millimeters into the part up until this step as shown over here. If I were to take a look at the simulation, you'll see that the tool will be working around this area over here up until that particular surface only, not going any further down on that material. Now, in our next operation, we'll be using the exact same tool as we did before, the 12 millimeter bullnose tool with a 0.5 millimeter radius. But if we go into our passes area, you'll see that we'll be working between the depths of -62 and -72. In other words, we'll be working from this surface up until this surface over there, only working in that area. Again, stepping down every 0.15 millimeters. taking again a quick look at the simulation, you'll see that the tool works exactly in those areas only. In our next operation, we'll be doing a horizontal finish on the part, working only on the flat floors of the part itself. If we take a look at the tool, we'll be using again a 12mm bullnose tool with a 0.5 millimeter radius. And if we go into our passes, you'll see we'll again be working on the lower areas on the bottom over here, on this surface and on this surface over here. If we take a look at our simulation, you'll see that the tool will only work on this area and in this area alone. No other areas were machined. Now in our final operation, we'll be working on these tapered walls around the part. For that, we've used the option of constant Z machining, and since HSM recognizes also tapered tools, we'll be using a 12-degree tapered end mill to machine out those walls itself. And since we are using a tapered end mill, in our passes, we can take large step downs of 10 millimeters on the part itself. If we take a look at the simulation, you'll see that the tool will work exactly on those tapered areas, stepping down every 10 millimeters as shown over here. For more videos on SolidCAM Professor, please go to our website, www.solidcam.com, and look for the tab called SolidCAM Professor. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.